Good morning, everyone. My name is Mark Andrews. I'm technical editor with Silicon Semiconductor Magazine for Angel Business Communications. Thank you for joining us today for this look into atomic force microscopy brought to you by our friends at Park Systems. Joining me today is Dr. Doru Florescu of Park Systems. Doru focuses on business development within the company. He has more than 20 years experience in analytical capital equipment manufacturing for semiconductor, data storage, and LED manufacturing. Doru's work has been featured in over 40 publications. And for those of you who haven't followed AFM in great detail, Park Systems truly is a leader in this area. AFM is a workhorse, if you will, across the semiconductor industry. And in fact, Park Systems Company, the Park Systems Company has service with just about every top major semiconductor manufacturer across the world, also used heavily in research work also. An important role. Park's inline AFMs are used widely by almost all the major manufacturers and frequently used in automatic defect review. Park Systems has an ongoing joint development program with our friends over at IMAC, a major world research organization that does some of the finest leading edge work out there right now. And their role is developing new protocols designed to increase semiconductor production yield and device performance. So today we'll be discussing Park Systems' new NX-TSH tip scanning technology for OLED and ultra-large samples, typically that goes into panels. And it's also the first tip scanning AFM designed for samples over 300 millimeters, hence the application in big panel displays. Doru, just to get things rolling here, I understand that the new NX-TSH tip scanning AFM is designed specifically for LED and organic LED panels, or OLEDs as they're often called. Are there particular challenges with these panels besides their very large dimensions?
Good morning, Mark, and thank you very much for having me on the program. I appreciate the opportunity to speak with you, and thank you for the good introduction that you provided to our technology. To answer your question, there are several challenges in designing and manufacturing these large panel displays. And it basically boils down to not just the large size, but to the size of the pixels and the size of the dots that create the colors. So we can assemble these dots together and create an image. So lateral, X, Y, and vertical dimensions are critical to the design and manufacturing of these large panel displays.
Okay, interesting. Now, can you please describe what sets the NX-TSH apart from other means that manufacturers might utilize to gain insights into how their devices are performing, or is AFM the standard?
Absolutely. Typically, our company, being a vertically integrated atomic force microscope company, we design and manufacture all our tools from the ground up. We like to focus on core, which is the atomic force microscope measurements, which are impurities, defects, or critical dimensions. And beyond core, we have techniques which we can utilize to measure electrical properties, magnetic properties, or any sort of material properties at this small scale. So for the tip scanning tool, the new tip scanning tool, it's an advancement on both fronts. It's a new tool that enhances our core offerings, and it has the ability to perform electrical measurements through IV curves at points of measurements. So it's really a comprehensive package that allows manufacturers to perform design, failure analysis, and manufacturing control for very large sample sizes.
Wonderful. I also, when I was reading about the product beforehand, so I would have more detailed information. I mean, I'm familiar, of course, with Park Systems products, but I understand that the tip scan head is also a unique system for alignment, positioning, and automated panel scanning. Yeah, and I know when I first saw the photograph of the system, I saw what I think of as a very typical AFM system, but then this rather interesting looking robot next to it. So if you could describe a little bit, please.
Sure. As part of our core technology and as part of getting accurate measurements, again, in X, Y, and Z, we have decoupled the X, Y motion from the Z in our standard AFM tools that we use in the semiconductor industry, such as NX wafer or NX3DM. The challenge for the tip scanning tool was to merge these two components into the same unit, which is the tip head. Once that was achieved, we placed this head on a gantry style mechanism that allows us to move the head and position it to any location on these flat panel displays.
Interesting, interesting. And now the gantry bridge system itself, it sounds like that would be a great way to improve productivity and quality and sort of take that human variability element out of it. Is that in fact one of the advantages also?
Absolutely. And that, to, to be honest with you, it's not just for the tip scanning head tool. Our tools are fully automated. So when you look at these types of measurements, you look at the collection portion, and then you look at the analysis portion. We have automated tools and automated recipes that allow the user to create these recipes, and the tool just performs the measurement, analyzes the data, and outputs all this information in standard SPC, statistical process control charts, that allow good and stable yield control.
Okay, wonderful. Now the Park AFM systems that I have seen before in actual operation, they employ a contactless approach to the scanning. So does the NX-TSH also get?
Absolutely.
Yeah. Okay.
Absolutely. It's based on our core technology of a very, very sensitive Z detector. Again, for these type of measurements, we call the AFM the world's most sensitive microphone. I mean, they're very, very susceptible to noise, to vibration. So a lot of integration challenges to be able to get this units to perform in a very quiet environment. So the challenge was to take the XY and merge it to the Z into the same unit, which was done for the tip scanning head. And once all the other components were controlled, we were able to integrate this onto the gantry such that we move to the measurement locations.
Oh, wonderful, wonderful. Now, can manufacturers gain, and I guess I should say, what can manufacturers gain in this approach in analyzing their devices when building next generation large panels? Is it better data, more accurate data?
I think it spans a wide range of applications, starting with the R&D. So, if you look at, as you mentioned, at OLEDs or LCDs like QLEDs, everything depends on the size. So how you control the size of the dots that emit the color, or the size of the filters that block the light. So, you can design more and more advanced devices. You can engineer these devices, and then you can take them to a pilot or a manufacturing line where you can control accurately at various points the manufacturing process.
Oh, wonderful, wonderful. Now, is it possible for customers? I know SemiCon West is virtual this year. So does Park System have demos set up, or how does this work if a potential customer would like to see the system in operation?
That's a good question, and we're very excited about the virtual conference. We do have a large virtual booth that will be manned by our applications and sales personnel, open for the entire duration of the show. We do have a lot of brochures and videos that we can walk people through, not only for the tip scanning head tool, but also for the NX wafer, NX3DM, which are other tools that we use in the manufacturing space. And we do conduct demos at our demo labs, both in US and headquarters in South Korea, where people can send us material or samples. The advantage of having the gantry style, if I go back to this, is that this technique is non-destructive. So whereas before people would have to take small parts or break displays, they can use the entire display for investigation, for design, for control of the manufacturing.
Wonderful, wonderful. Doru, I see that we're just about running out of our time here. Is there anything that you'd like to add to wrap up with regard to the Park Systems line?
I believe, we've been in the business for many, many years now. We have more than 1,800 tools installed, over 32 patents. I believe Park Systems is the first company that went IPO with the core technology of AFM. So we consider ourselves the experts, as if you're visiting a doctor, you want to go to a specialist. So I encourage anybody to visit us and bring us problems. And, we like to address problems. We like problems. We like to look at defects. So we like to do inspection. We like to look at critical dimensions. So we like to do metrology, and we like to help the process of, device manufacturing from inception to full production.
Oh, fantastic. Everyone, I'd like to thank Dr. Doru Florescu. Sorry, I knew that no matter how much I practice, I would get your last name. Please forgive me, Doru. Thank you for being with us today. Thank you for Park Systems, and thank you for your great products that are benefiting our industry at this time where we're facing more challenges than we ever have. Thank you again.
Thank you, Mark, and nice to be here with you.